Hello, today we're doing a worksheet on probability of combined events, paper 4. This is the third video on this topic. The very first one was probability of single events, that is usually covered in grade 8th or 9th depending on which school we're talking about. And then there was probability of combined events that we did from paper 2. And now the third video, which will conclude the topic of probability, is probability of combined events, and now we're discussing all the questions from paper 4. Okay, so Ravi spins a biased 5-sided spinner numbered 1 to 15. The probability of each number is shown in the table. So the table shows that probability of getting number 1 is 1 upon 6, 2 is 1 upon 4, and so on. Find the value of x. So we know that the sum of all probabilities equals 1. So we'll add all of these values equated to 1, and we should get our answer 1 upon 6 plus 1 upon 4 plus 1 upon 3 plus 2x equals 1. Solve this in your calculator. I'm going to do 1 minus fraction 1 upon 6 minus fraction 1 upon 4 minus fraction 1 upon 3, which is giving me 2x equals 1 upon 4, which gives me x equals 1 upon 8. Okay. Part B, Ravi spins the spinner once. Find the probability that the number is 2 or 3. Or means add, so what's the probability of getting 2? That's 1 upon 4. Or means add, and probability of getting 3 is 1 by 3, and the answer will be 7 upon 12. Part C, Ravi spins the spinner twice. Find the probability that the number is 2 both the times. So we have to find in part C1, we have to find probability of getting 2 and then again 2. So probability of getting 2 is 1 upon 4, and again another time another time getting 2 is again 1 upon 4, so the answer is 1 upon 16. Part 2, the sum of the numbers is 3, which means we're finding the probability of 1 and then getting 2, or probability of 2 getting 2 first and then 1. Either we find these separately, or what I'll do, I'll just multiply the first probability with 2, so that I'm incorporating both the scenarios, 1 and then 2 and then 2 and then 1. So 2 times, what's the probability of getting 1? 1 upon 6. What's the probability of getting 2? 1 upon 4. So we're getting 1 upon 12. Okay. Part D, Ravi spins the spinner 72 times. Calculate how many times he expects the number 1. So for this, all you do is multiply the probability 1 upon 6 with 72. So we do, for part D, we simply do 72 times 1 upon 6, which gives 12. Expected number of value, expected value. Okay, next question. Sushila, Ravi and Talika each have a bag of balls. Each of the bag contains 10 red balls and 8 blue balls. Okay, part A. Sushila takes one ball at random from her bag. Find the probability that she takes a red ball. So simply find the probability of getting a red ball. We have 10 red balls and total 18 balls. So the answer will be 5 upon 9. Part B. Ravi takes 2 balls at random from his bag without replacement. Find the probability that one ball is red and the other ball is blue. So we're finding the probability of red ball and blue ball. We will multiply this with 2, because we can get the first ball can be red and the second ball can be blue, or the other way around. The first ball can be blue and the other ball can be red. So we have to either find one of the probability and multiply it with 2, or find both these probabilities separately. So what we'll do, we'll find one probability, red, blue, and multiply it with 2, so that we're also considering blue and red. Okay, so 2 times probability of getting red is 10 upon 18 times, what's the probability of getting blue? 1, 2, 3, 4, 5, 6, 7, 8 blue balls. We have 8 blue balls, and now we'll have 17 blue balls left, because the question says without replacement. Since the first ball that was selected was red, so that has been kept out of the box. So now we're one ball short. So we'll do 8 upon 17. Okay, so this should give 80 upon 153. Part C. Talika takes 3 balls at random from her bag without replacement. Calculate the probability that the 3 balls are the same color. Okay, so same color means that either we get red and then red and then red, or we get a blue ball, then again another blue ball, and then again another blue ball. So let's find this probability. Probability of getting first red would be 10 upon 18, second red would be 9 upon 17, and third red would be 8 upon 16, or means plus getting the first blue ball would be 8 upon 18, then getting another blue ball would be 7 upon 17, and then similarly 6 upon 16. Why are we decreasing the numerator and denominator by 1 is because, let's say in the case red, if we get a red ball first, we put it outside of the bag. So now inside we will have 9 blue balls and total 17 balls left. So hence you write 9 upon 17. Then when you get the second red ball, you take the second ball outside of the box as well. So now then you're left with 8 red balls and 16 balls in total. So you do 8 upon 16. That's why the numerator and denominator keeps decreasing, because it says without replacement here. Anyway, so then you find this product and sum, and you get 11 over 51. Next question. The table shows information about the time, T minutes, taken for each of 150 girls to complete an essay. A girl is chosen at random. Work out the probability that she took more than 100 minutes to complete the essay. So how many girls took more than 100 minutes to complete the essay? That's 22. And how many girls do we have in total? 150. So the answer will be 22 upon 150, which rounded off will give this answer here, 11 upon 75. So rounded off, cancelled. When we simplify this, when we simplify 22 upon 150, you will get 11 over 75, which is the answer for part D. I haven't copied A, B, C because they were not related to probability. Okay, part E. 2 girls are chosen at random. Work out the probability that to complete the essay they both took 75 minutes or less. Okay, so how many girls take 65 minutes or less? 10 girls take 65 minutes or less. So 2 girls are chosen. Probability that first takes 65 minutes or less would be 10 upon 150 girl. Now that girl is removed from the set. So now 9 girls are left who take less than 65 minutes, and total 149 girls are left. When you multiply this, you get 3 upon 745. Part 2. One took 65 minutes or less and the other took more than 100 minutes. So again 10 girls take 65 minutes or less, so the probability of this will be 10 upon 150 times 22 girls take 100 minutes and more, so 22 upon 1 girl has already been selected from this. So now the denominator will become 149, and also since it says one took 65 minutes or less and the other took more than 100, it does not say the first one takes 65 minutes and the other one takes 100 minutes or more. It says one took 65. So we also have to consider the case that the first one is from the 65 pool and the other one is from the 100 pool, or the first one would be from 100 pool and the other one would be from the 65 wala pool. So you have to multiply this probability with 2 as well. Again, why are we doing that? Because the question is not saying that the first girl that's chosen takes 75 minutes or less and the other one takes 100 minutes or more. So it could have been that the first one takes 100 minutes or less, and the other one 100 minutes and more, and the other one takes 65 minutes or less. So we have to multiply this with 2. Okay, and the result would be 44 upon 2235. Robert buys one energy saving bulb and one halogen bulb. The probability that energy saving bulb lasts longer than 3500 hours is 9 upon 10, which means the probability that this bulb would last less than 3500 hours would be 1 upon 9, the remaining probability. Okay, the probability that the halogen bulb lasts longer than 3500 is 3 by 5. That means 2 by 5 is the probability that the halogen bulb will not last more than 3500 hours. Okay, work out the probability that exactly one bulb lasts longer than 3500. So let's say, since 2 bulbs are being chosen, so let's say the first bulb lasts longer than 3500 hours. Let's say, which one was that? Energy saving bulb lasts for more than 3500 hours, and the other bulb, halogen bulb, does not last for more than 3500 hours. Or we also have to consider the case where the energy bulb does not last longer, but halogen bulb does last longer than 3500 hours. So what's the probability of energy bulb lasting more than 3500 hours? It's 3 upon 10. What's the probability of halogen bulb not lasting more than 3500 hours? So that's 2 upon 5, or means plus energy bulb not lasting more than 3500 hours is 1 upon 9 times halogen bulb lasting more than 3500 hours is 3 upon 5. Find this product, and the answer should be 21 upon 50. Yikes, I made a huge mistake. The probability here would be 1 upon 10. I don't know why I wrote 1 upon 9. It's 1 upon 10. Probability of bulb lasting longer than 3500 is 9 upon 10. Then the probability of that bulb not lasting more than 3500 hours would be 1 upon 10. Similarly, this would be 1 upon 10, and then we'll get this answer. Gareth has 8 sweets in the bag. 4 sweets are orange flavored, 3 sweets are lemon flavored, and 1 is strawberry flavored. Part A, he chooses 2 of the sweets at random. Find the probability that the 2 sweets have different flavors. That means we're finding probability of, let's say, getting orange and lemon, and also there's a case of getting lemon first and then orange second. So we'll multiply with this 2. Similarly, 2 times probability of getting orange and strawberry plus 2 times probability of getting strawberry and orange. I'm multiplying it with 2 because the first case can be orange and the second sweet can be lemon, or the other way around. So we're multiplying with it with 2. This is one way of doing it, or there's another easier way, or another alternate way of doing it is that do 1 minus probability of getting orange and then again orange, minus probability of getting lemon and then again lemon, minus probability of getting red and then again red. This probability would be 0 because we can't get red and then again another red. So I'll do the second case because it requires lesser steps, and let's see if I get the answer or not. 1 minus, what's the probability of getting orange? 4 upon, how many sweets do we have in total? 8 times 3 upon 7 minus probability of getting lemon, 3 upon 8, and another lemon would be 2 upon 7. There's no p here. Let's see, what do we get? Yes, we do get the answer, 19 upon 28. Part B, Gareth now chooses a third sweet. Find the probability that none of the 3 sweets is lemon flavored. So for part B, I'm finding the probability of not getting lemon, then again not getting lemon, then again not getting lemon. Probability of not getting lemon would be 1, 2, 3, 4, 5. 5 upon 8 times 4 upon 7 times 3 upon 6. This should give 5 upon 28. Next question. Coins are put into a machine to pay for parking cars. the probability that the machine rejects a coin is 0.05, which means probability that the machine accepts the coin would be 1 minus 0.05, which gives 0.95. So either this or 0.95 is the probability of acceptance of the coin. Okay. So Adhira puts 2 coins into a machine. Part 1, calculate the probability that the machine rejects both coins. So that's simply probability of rejection times again probability of rejection, which is going to give 1 upon 400. For part 2, calculate the probability that the machine accepts at least 1 coin, which means either it's going to accept the first coin, which is going to be 0.95, and then reject the other coin times 0.05. So accept, probability of accept and reject. And it could have also been reject and then accept, which means the first coin got rejected but the second coin got accepted. So we multiply this with 2 plus probability that both coins get accepted, because it says at least 1 coin gets accepted, which means both can also get accepted. So we'll find accepted. So we'll do probability of accepted and accepted. So 0.95 times 0.95. This product and sum should give 399 upon 400. So huge probability of that happening. Part B, Raj puts 4 coins into the machine. Calculate the probability that the machine rejects exactly 1 coin. Okay, which means we are entering 4 coins in the machine, not we, Raj, and 1 should get rejected and the others should get accepted. So I have shown the case that the first one got rejected, the other 3 got accepted. There are another 3 cases as well, which is accept, reject, accept, accept, and then accept, accept, reject, accept, and then, sorry, I think I got that wrong. Reject, accept, accept, accept is the first case, then accept, reject, accept, accept, then accept, accept, reject, accept, and then the final case is that the first 3 get accepted, accept, 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 and the last one gets rejected. So there are 4 such cases, so I multiply this with 4. So 4 times probability of rejection is 0.05 times probability of acceptance, and multiply it 3 times 0.95. So this should give this number 6859 upon 40000. Next question, a box contains 20 packets of potato chips. 6 packets contain barbecue flavor, then 10 packets contain salt flavored chips, and then 4 packets contain chicken flavored chips. Okay. Maria takes 2 packets at random without replacement. Show that the probability that she takes 2 packets of salt chips, flavored chips, is 9 upon 38. Okay, let's see. She takes 2 packets at random without replacement, and we have to see that these are salt flavored chips. So we have 10 salt flavored chips out of 20 times, if one of these is selected, that means we're left with 9 upon 19. So this should give 9 upon 38. Yes, okay. This was 1. Part 2 is find the probability that she takes 2 packets of different flavor chips, which means that she gets barbecue flavor and then salt flavor. So probability of getting barbecue flavor and then salt flavor, multiply it with 2, because she might get the first chip might be salt flavored and the other chip might be barbecue flavor, plus 2 times salt and chicken flavored, plus 2 times probability of getting chicken flavored and then barbecue flavored. Okay, so either do this, or what I'll do instead is I'll do 1 minus probability of getting chicken and then chicken flavored, minus probability of getting barbecue and then barbecue flavored, minus probability of getting salt and then salt flavor, because these are the cases we should not get. Other than these, any case is acceptable. So the total probability is 1. When I subtract these 3 cases from 1, I get all probability of the all remaining cases. So let's see, I should get 1 minus probability of getting chicken is 4 upon 20 times 3 upon 19, minus probability of getting barbecue flavored twice is 6 upon 20 times 5 upon 19. Oh, there's no p here. Minus probability of getting salt flavor 10 upon 20 times 9 upon 19. Okay, find this product and we should get 62 upon 95. Okay, part B. Maria takes 3 packets at random without replacement from the 20 packets. Find the probability that she takes at least 2 packets of chicken flavored chips. Okay, so that means we're finding the probability of getting a chicken flavor, then again chicken flavor, and then not getting a chicken flavor. Also, we might get chicken first, not we, Maria, sorry, and then not chicken, and then chicken flavored, or there's a third case that the first one is not chicken, the other 2 is chicken. So what, instead of finding all these 3 probabilities and then adding them, we can simply multiply this with 3 and not find these at all. So I'll do 3 times, what's the probability of getting chicken flavored chips? 4 upon 20. Again, chicken flavored chips, that's going to be 3 upon 18. Then not getting chicken flavored chips, how many not chicken flavors do we have? 10 plus 6, which is 16 upon 17 chips are left now. So this should give the answer 5 upon 57. Oh, I made a huge blunder in this question. Actually, two huge blunders. The first of them is that why did I write 18 here? This was 19. 1 minus 20 is 19. So this is 19 and this is 18. So that's the first mistake. Okay. Then I did not read the question properly. It says at least 2 packets of chicken flavor. That means she may have 2 packets of chicken flavor and 1 non-chicken flavor, or she may have all 3 chicken flavors. Chicken, chicken, chicken. I did not add this probability. So this probability needs to be added to the previous answer. So we'll do plus probability of getting chicken flavor 4 upon 20 times, very careful now, 19 and then 18 here. And 4 chicken flavored, then 3 chicken flavored, then 2 chicken flavored left. So this would now give the answer 5 upon 57. Okay, next question. Preeti picks a card at random from the 11 cards below here and does not replace it. She then picks a second card at random and does not replace it. Find the probability that she picks, part 1, letter L and then letter G. So probability of getting letter L is, we have 1 letter L and total 11 cards time, and then G. So how many G's do we have? We have 1 G again. So 1 upon 10, since it says without replacement. So the answer would be 1 upon 110. Okay. Part 2, the letter E twice. So for part 2, we first get letter E. How many E's do we have? 3 E's in total. So 3 upon 11 times, again getting an E. The probability for that would be 2 upon 10. So the answer would be 6 upon 110 or 3 upon 55 as written in the marking scheme after simplification. Part 3, 2 letters that are the same. So that means she either gets probably E and then again E, and which other letters do we have twice? N is twice. So probability of N and again N. So we already have probability of E and E, which is 3 upon 55, plus probability of N and then again N. Probability of N is 2 upon 11 times 1 upon 10. So we should get 4 upon 55 as the final answer. Let's see. Part B. Preeti now picks a third letter at random. Third card at random. Find the probability that the three letters are the same. So that's only going to be when she gets E and then again E and then again E. So probability of getting E the first time is 3 upon 11, then 2 upon 10, then 1 upon 9, which should give 1 upon 165. Part 2, do not include the letter E. So I'm finding probability of not getting E in the first draw, then again not getting an E, and then not getting an E again. So what's the probability of not getting an E? So I see 3 E's. That means I have 8 not E's. Yes, so 8 upon 11 times, again not getting an E, 7 upon 10 times 6 upon 9. This should give the answer 56 upon 165. Part 3 includes exactly 2 letters that are same, which means that we might have the case probability E and then not E. But I'll have to multiply this with 3 because first may be E, second may be E, and then third is not E, or maybe the middle one is not E, or maybe the first one is not E. So there are 3 cases of getting 2 E's and 1 non-E. So I multiply that with 3. Similarly, plus 3 times probability of getting G and then G and then not G. So let's see, 3 times probability of getting an E, E and not E. So that's going to be 3 upon 11 times 2 upon 10 times what upon 9. So how many non-E's did we have from the start? 8. Plus 3 times G. How many G's did we have? 2. So no, we did not have 2 G's. We had 2 N's. So this should be N actually, not G. So let me fix this. This is N and not N. So probability of getting an N is 2 upon 11, then 1 upon 10, and then how many non-N's do we have? We have 9 non-N's. So 9 upon 9, which is a definite probability. So let's see what product do we get. We get 1 upon 5, which is the correct answer. Thank God I was so not in the mood of doing this all over again. The diagram shows 5 cards. Donald chooses a card at random. Write down the probability that the number of dots on this card is an even number. How many even numbers cards do we have? 4. So total cards are 5. So the answer would be 4 upon 5. After that, write down the probability that the number of dots on the card is a prime number. I see 1, 2, 3, 4 prime numbers. So 4 upon 5 is again the answer. Part B. Donald chooses 2 cards at random without replacement. He works out the total number of dots on these cards. Part 1. Find the probability that the total number of dots is 5. So that can be achieved from getting 3 and then 2, or getting 2 and then 3. So I'll multiply this with 2. So 2 times probability of getting a 3 is 1 upon 5 times probability of getting 2 is 3 upon 4, which gives 3 upon 10. Okay. Part 2, find the probability that total number of dots is an odd number. So I get an odd number by getting 3 and then 2, or again, yes, 2 and then 3, or by adding 4 and then 3. So plus 2 times getting 4 and then 3. So the product will be 2 times probability of getting 3 is 1 upon 5 times probability of getting 2 is 3 upon 4, plus 2 times probability of getting 4 is 1 upon 5 times probability of getting 3 is 1 upon 4. And the answer is 2 upon 5. Next question. Sandra has a fair 8-sided spinner. The numbers on the spinners are 3, 4, 4, blah blah blah. Sandra spins the spinners twice and records each number it lands on. Find the probability if both numbers are 8. So for part A, we're finding the probability of getting 8 and then again 8. So since it's a fair spinner, the probability of getting each probability of getting an 8 would be, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 sectors, so probability of getting an 8 would be 1 upon 8. And then in the other spin, the probability of again getting an 8 would be 1 upon 8. So the answer is 1 upon 64 for part A. Part B, two numbers are not both 8. So in part A, we already have the probability of both numbers being 8. Part B says that the two numbers are not both 8, which means we simply have to do 1 minus the previous probability, which will simply give 63 upon 64. Okay. Part C, one number is odd and one number is even. So that means we have to find the probability of an odd number, getting an odd number and then an even number, or getting an even number first and then odd number later. So that's why I'm multiplying this probability with 2. So probability of getting odd number is, how many odd numbers do we have? I see 2 5s, 1 3. So 3 upon 8 times probability of getting even number would be, in the next spin, probability of getting an even number will be 5 upon 8. So the result would be 15 upon 32. Part D again, total of the two numbers is at least 13, which means we can find probability of getting 6, 7, which two numbers would we add to get 13 or more. So 8 and 6 added would give 13 and more. So one case is 8 and 6 because their sum would be 14. And again I'll multiply this with 2 because I have to cater the case of 6 and then getting an 8 as well. So 2 times probability of 8 and 6 plus, do we have any other option? What about 8 and 5? 8, 9, 10, 11, 12, 13, yes. So plus 2 times probability of 8 and then 5. I'm multiplying it with 2 because I also have to consider the case of getting 5 first and then 8. And what about any other case? What about 8 and 4? 8, no, that's 12. So what about 6 and 5? No, that's not 13 either. That's 11. So I guess these are the only two cases. So 2 times probability of getting an 8 is 1 upon 8 times probability of getting a 6 in the next spin is 1 upon 8 as well. Plus 2 times probability of getting an 8 and is 1 upon 8 times probability of getting 5 in the next spin is 2, since I see 2 5s upon 8. Oh, there's another case that I did not consider, that is probability of getting 8 first and then again first. Since both of these numbers are the same, so I'm not multiplying 2 with it. So plus 1 upon 8 times 1 upon 8. So now this would give us 7 upon 64. Part E, the second number is bigger than the first number. So which cases should we consider for this? For part E, second number is bigger than the first number. So what about 3 and then 4, and there's also probability of 3 and 5, probability of 3 and 6, probability of 3 and 8. So these are too many numbers. What I can do is find probability of 3 and then probability of a number bigger than 3. So bigger than 3, that will cater all the cases, plus probability of 4 and then bigger than 4, and then similarly for 5, 6, 7 and 8. So these are all the cases. Probability of getting a 3 in the first spin and then a number bigger than 3. Probability of getting 4 in the first spin and then getting a bigger number than 4. Probability of getting 5 in the first spin, then a bigger number after that, and probability of getting a 6 and then get a number bigger than that. I'm not going to use probability of 8 and then a number greater than 8 because there's no number greater than 8. So let's find all these probability. Probability of getting 3 is 1 upon 8 times probability of getting a number bigger than 8 in the next spin. So that's going to be 1, 2, 3, 4, 5, 6, 7. 7 numbers are bigger than 3. Plus probability of getting a 4 is 3 upon 8 times probability of getting a number bigger than 8 in the next spin, which is 5 upon 8. Plus probability of getting a 5 is 2 upon 8. And in the next spin, probability of getting, oh, why did I write 5 over here? Sorry, I made a mistake. So probability of getting a 4 is 3 upon 8. Probability of getting a number bigger than 4 is 1, 2, 3, 4. 4 upon 8. Plus probability of getting 5 is 2 upon 8 and probability of getting a number bigger than 5 is just 2 upon 8 because we're choosing 6 and 8. And then probability of getting 6 is 1 upon 8 and then in the next attempt getting a number bigger than 6 is 1 upon 8. Okay, let's see what does this give us. This gives 3 upon 8, which is the answer. Next question. The diagram shows a circular board divided into 10 numbered sectors. When the arrow is spun, it is equally likely to stop in any sector. Complete the table below to show the probability of the arrow stopping. So what is the probability of getting 1? So 1, 2, 3, 4. We have 4 ones and total we have 10 sectors. So 0.4 is this, and then getting a 3 would be 1 upon 10, so 0.1. Also you can check by adding in all these probabilities and seeing if we get 1 or not, because sum of all probabilities is 1 and we do get 1 by adding all these numbers. Okay, part B. The arrow is spun once. Find the most likely number. So which one of these numbers has the highest probability? It's 1. So the answer is 1. 1 is the most likely number. Probability of a number less than 4. So probability of a number less than 4 would be all these 3 cases. So that's going to be 0.4 plus 0.6 plus 0.1, which is 0.7. Okay. The arrow is spun twice. Find the probability that both numbers are 2. So we're getting 2 in the first spin and then 2 in the next spin. So the answer is 0.04. 0.04. Okay. Next is the first number is 3 and the second number is 4. So we're going to do 0.1 times 0.3, which is 0.03. The numbers add up to 4. So 3 and 1 add up to 4 and 2 and 2 add up to 4. So probability of, so for part 3, we're taking the case of probability of getting 1 and 3, and there's also another case 3 and 1, so I'll multiply this with 2, plus probability of 2 and 2. So probability 2 times probability of 1 is 0.4 times probability of 3 is 0.1 plus probability of getting 2 and then again 2. So this should give us 0.12. Part D. The arrow is spun several times until it stops at 4. Find the probability that this happens on the third spin, which means the first spin should not be a 4. The second spin should not be a 4 either. The third spin should be a 4. So what is the probability of not getting a 4 in the first spin? That's this. 0.4 plus 0.2 plus 0.1, which is 4, 5, 6, 7, 0.7. Then again in the next spin not getting a 4 will have probability 0.7. Then in the third spin getting a 4 would have probability 0.3. This product should give the answer 0.147. Next question. A bag contains red beads and green beads. There are 80 beads altogether. The probability that a bead chosen at random is green is 0.35. Which means that the probability that the bead is red would be 1 minus 0.35. 1 minus 0.35, which gives 0.65. So probability of the bead being red is 0.65. Okay. Find the number of red beads in the bag. So to find the number of red beads, simply multiply this probability with the total number of beads. So we do 80 times the probability of getting a red bead, which is 0.65. This should give the answer 52 equals 52. Okay. Part 2, which is Marcos chooses a bead at random and replaces it in the bag and replaces it in the bag. So he chooses a bead and then he replaces it. So the bead goes back. He does this 240 times. Find the number of times he would expect to choose a green bead. So simply multiply 240 with the probability of getting a green bead. So 240 times 240 times probability of getting a green bead, which is 0.35, which gives 84. Okay, part B. A different bag contains 2 blue marbles, 3 yellow marbles and 4 white marbles. Okay, Homa chooses a marble at random, notes the color, then replaces it in the bag. She does this 3 times. Find the probability that all 3 marbles are yellow. So probability of the first marble being yellow is 1 upon how many total marbles do we have? 4, 5, 6, 7, 8, 9. Then she puts it back. So the probability, this is 3 upon 9. Probability of getting a yellow marble is 3 out of 9. And then again getting a yellow marble is 3 upon 9 because she places the marble back. Unlike in the previous questions where the question said without replacement. So now this is with replacement. So the original count goes back. So the answer for this should be, simplified answer should be 1 upon 27. Okay, this is part B, 1, this. Okay, B part 2, all 3 marbles are different colors. That means the first can be, let's say, blue, the second one can be yellow, and the third one can be white. So this is one case. Or there are multiple such combinations, like this is the first combination, second combination can be yellow, blue, white, third combination can be yellow, white, blue. Similarly, another combination can be yellow, then blue, then white, then yellow, then blue, then yellow, then white, and then let me just write all the combination down. I'm even getting confused. I'll write all of them down, then we'll see how many combinations are we getting. Okay, so there are actually 6 possibilities of getting 3 different colors, like we can see here. So what we'll do, instead of finding all these 6 probabilities separately, what we'll do is do 6 times. Let's find probability of this first one. So probability of getting a blue is 2 upon 9 times probability of getting a yellow is 3 upon 9 times probability of getting a white is 4 upon 9. So this should give the answer 7 upon 10. No, not 7 upon 10. 16 upon 81. Let's see. Yes, that's the answer we get. So now on to part C, which says another bag contains 2 green counters and 3 pink counters. Teresa chooses 3 counters at random without replacement. Find the probability that she chooses more pink counters than green counters. So that means we're looking at the option pink, probability of getting pink, then again pink, and then green, or probability of getting pink, and pink. So let's find this probability. What's the probability of getting a pink, which is 3 out of 5. Then is this, another bag contains this, this is 3. Now it's without replacement. So we'll have to decrease the denominator. Next time the number of pink counters become 2 and total number of counters become 4, and the next time total number of counters become 3 and the green counters are still 2. Plus now we have to do the case pink, pink, pink. So keep decreasing the numerator and denominator by 1. So let's see what we get. Oh no, but before that we have 3 such cases: pink, pink, green, or pink, green, pink, or green, pink, pink. So multiply this with 3, which means multiply this with 3. Then we will get the answer 7 upon 10. Next question. A bag contains 4 red marbles and 2 yellow marbles. When asked, picks 2 marbles at random without replacement. Find the probability that the marbles are both red. So for part A, we have to find the probability of getting red and again red. The question is without replacements, we need to keep decreasing the denominator. So probability of getting a red marble in the first attempt is 4 upon 6, and then again getting a red marble is 3 upon 5. The answer will be 2 upon 5. Part 2, the marbles are not both red, so that means we have to find just the remaining probability. So the probability of both marble being red is 2 upon 5. The probability of both marbles not being red is 3 upon 5. Part B. Another bag contains 5 blue marbles and 2 green marbles. Brian picks 1 marble at random without replacement. If this marble is not green, he picks another marble at random without replacement. He continues until he picks a green marble. Find the probability that he picks a green marble on his first attempt or second or third attempt. Okay. So what's the probability of getting a green marble in the first attempt, or what's the probability of getting a green marble in the second attempt? So that means in the first attempt he is getting a blue marble. Or what's the probability of getting a green marker in the third attempt? Marble in the third attempt is blue, then again blue, and then green. So find all these probabilities and add them. Probability of getting green marble is 2 upon 7, or means plus. Probability of getting blue marble is 2 upon 7. Then probability of getting a green marble is 2 upon 6, since this is without replacement, or means plus. Blue's probability is 5 by 7, and next blue's probability is 4 upon 6, since this is without replacement. The next green's probability is denominator will be reduced by 1. Green marbles are still 2 in the bag. So this should give 5 upon 7. Next question. The diagram shows 2 fair dice. Number on dice A are these, number on dice B are these. When a dice is rolled, the score is the number on the top face. Dice A is rolled once. Find the probability that the score is not 3. So in dice A, probability of not getting a 3 is, how many times are we not getting a 3? 5 times. How many numbers do we have in total? 6. So the probability is 5 upon 6. Part B. Dice A is rolled twice. Find the probability that the score is 0 both times. So probability of getting 0 once is 2 upon 6, and then again probability of getting 0 is 2 upon 6, which gives us 2 upon 9. Sorry, 1 upon 9 as the final answer. 1 upon 9. Okay. Then we have part C. Dice A is rolled 60 times. Calculate an estimate of the number of times to score a 0. So do we have a probability of getting 0? Yes. Probability of getting 0, whatever that is, multiply it with 60 simply. So probability of getting 0 is 2 upon 6. So the answer would be 20. Part D. Dice A and dice B are each rolled once. The product of the score is recorded. Complete the possibility diagram. So you find all the products. 1 times 1 is 1. Similarly, 1 times 1 is 1. Write all these products. 1 times 2 is 2. Let me finish this up. Okay, so I filled up the possibility diagrams. Part 2. Find the probability that the product of the score is 2. So how many times do we see a 2? 1, 2, 3, 4, 5, 6, 7 times. and how many numbers do we have in total? 1, 2, 3, 4, 5, 6. 6 times 6 is 36. Actually no, 2 is 9 times. 2 is at all these places, so 2 is 9 times. So the probability will be 9 upon 36, which gives 1 upon 4. A number greater than 3. So how many times do we have a number greater than 3? 1, 2, 3, 4. So 4 times the number is greater than 3. So the probability will be 4 upon 36, which is 1 upon 9. Part E. Eva keeps rolling the dice B until 1 is scored. Find the probability that this happens in the 5th roll. Alright. So 1 should be scored in the 5th roll. That means in the first roll, we're doing part E here. 1 should not be scored. In the second roll, 1 should not be scored. 1 should not be scored again. 1 should not be scored again. 1 should be scored in the 5th roll. So let's find the probability of not getting 1 in die B, right? We're talking about die B. Yes. What's the probability of not getting 1? 1, 2, 3, 4. 4 out of 6 times we won't get 1. Similarly, we won't get 1. 4 out of 6, 4 out of 6. 4 upon 6, and probability of getting 1 is 2 upon 6. Find this product, and it should be 16 upon 243. Next question. The diagram shows a spinner with 6 numbered sections. Okay, some of the sections are shaded. Each time the spinner is spun, it stops on one of the 6 sections. It is equally likely that it stops on any one of the sections. The spinner is spun once. Find the probability that it stops on a shaded section. We have 4 shaded sections. We have total 6 sections. So the probability is 4 upon 6, which simplifies to 2 upon 3. Okay. Section is numbered 1, so we have 3 section numbered 1, and we have total 6 sections, 3 upon 6, which simplifies to 1 upon 2. A shaded section numbered 1. So find the probability that it stops on a shaded section number 1. So 2 shaded sections are 1 upon their total 6 sections. So 2 upon 6 is the answer, which simplifies to 1 upon 3. Part 4. A shaded section or a section numbered 4. So, or a shaded section, how many shaded sections do we see? 4. Or a section numbered 1, so which means we're talking about this case or this case or this shaded section or a section numbered 1. So these are 5 sections. So the answer would be 5 upon 6 for this one. Okay, part B. A spinner is now spun twice. Find the probability that the total of the 2 spins is 20. So the only way we could get a 20 is by getting 10 and then 10. So probability of 10 and again 10. So that means get 1 upon 6 times 1 upon 6, which gives 1 upon 36. Okay, getting an 11. 11 can be obtained by getting 1 and then 10, or 10 and then 1, which means we multiply this probability with 2 instead of doing both the cases separately. So 2 times probability of getting 1 is 3 upon 6 times probability of getting 10 is 1 upon 6. So that is giving 1 upon 6. Okay, part C. The spinner stops on a shaded section. Find the probability that this section is numbered 2. So the question is telling us that it stops on a shaded section. That means denominator is now 4. So the denominator will have these 4 options, and find the probability that this section is numbered 2. So only one of the 4 sections is numbered 2. So the probability will be 1 out of 4. So 1 out of 4 is the answer here. Part 2. The spinner stops on a section numbered 2. Find the probability that this section is shaded. So if it stops at number 2, that means denominator has 2 values. So 2 in the denominator, and shaded section, that is number 2, is only 1. So 1 upon 2 is the answer. 1 out of 2 chances we will land on the required case. Okay, part B. This spinner is now spun until it stops on a section number 2. The probability that this happens on the nth spin is 16 upon 243. Find the value of n. Okay, let's read the question again, which says that the spinner is now spun until it stops on a section number 2. Find the probability that it happens on the nth spin. The probability that this happens on the nth spin is 16 upon 243. Find the value of n. Okay, so that means we're getting the cases of not 2, not 2, not 2, and then eventually we get a 2. And the probability of this happening is 16 upon 243. We have to find the value of n, which is how many times is the spinner spun. Okay, so what is the probability of not getting a 2? Probability of not getting a 2 is 1, 2, 3, 4, 4 upon 6, right? And this happens, let's say, t times, all right? And then the final answer should be, the final value on the spinner is 2. So the probability of that happening is 2 upon 6. So the answer should be 16 upon 243. I have shown that not 2 happens t times, and then 2 happens whose probability is 2 upon 6, and the sum should be, or the product should be, equals to this. In fact, instead of writing t here, let me write n minus 1, because not 2 happens n minus 1 times, and then 2 happens on the nth spin, and not 2 happens in the n minus 1 spins. So I have written n minus 1 instead of t, so that I have n in the equation. Alright, now let's simplify this. So this would become 2 upon 3 power n minus 1, take everything else to the other side, 16 times 6 divided by 243 times 2, this gives 16 upon 81. Now we have to find the value of. Okay, so the easiest way of solving this equation is simply by hit and trial, substitute some values of n here, and then see when this left hand side becomes equals to 16 upon 81. So start with, obviously we can't start with 1, because 1 minus 1 will make 0, and any number with the power 0 on it becomes 1. So start with 3, I think. Try 3, 4 and 5, and you'll notice when you enter n is equals to 5 in your calculator and enter 2 upon 3 power 4, when you enter 5 minus 1, which is 4, you'll get 16 upon 81, which means the value of n is 5. So that's how you'll get the value of n by hit and trial.